And that's not what I wanted to do, but all right. So, any general questions? First off, any general questions about the project at this point, right? One thing I want to stress, just in case there's anybody out there, is that what I'm expecting to see is that things like the player and any objects that the player is going to interact with, including the room, including anything else, there shouldn't be sort of this notion of an array, a grid that has locations in it. What I really want to see is that the objects are objects and that they have positions and they have other properties that allow us to interact with them, right? So a room might have a position and a width and a height. A key might have a position and maybe a radius, or maybe you use just the width to indicate the radius, that sort of thing, right? You shouldn't be looking into an array for sort of stuff. One of the other key things about that is that I want to see the interactions with those objects. When I'm looking for seeing those interaction objects based on some of the mathematical stuff that we've talked about, right? Things like taking this point and this point, using vector 2 distance to set, oh, okay, I'm within a certain distance, therefore I need to do something, right? So as you're checking things, that's the kind of thing that's going on. Or if you want to figure out, be fancy, and say, oh, something's up to the northeast. Subtracting 2 points will give you a vector that indicates the direction. And then you can look at the x, which will give you the east-west sort of orientation. And you look at the y, which will give you the north-south orientation, for example. Or off in front of you, off to your left, off to your right, however you want to do it, right? So this is the dx, and this is dy, right? The difference in x, the difference in y. Didn't mention that last time, but just in case a light bulb goes off for you because I put the d's in front of them, that's a good thing, right? So ultimately, this is 1 point. To get to this point, the difference between the two is like adding that much x and that much y, right? So we can do all kinds of cool stuff with that information. So that's the sort of thing I'm looking for, right? And the other thing about that is generally, and I've put some bonus stuff in the slides to talk about these things in general, but positions and vectors and offsets and so on, any good engine, most engines, we're talking about floating point relationships, right? So non-integer kind of stuff. It might be convenient for you right now to say, if you move x, you move 1 meter. If you move y, you move 1 meter, and some combination of that, right? That's certainly convenient, certainly valid, and so on. And maybe when you position all of your objects, you position them on even numbers. But you want to make sure, in looking at your equations and looking at your approaches to things, if suddenly an object was at 4.6, or the player was at 3.2, would that break everything? And if that does break everything, well, that might be something you want to be kind of careful of, right, or cognizant of, aware of. Because, in a real engine where we're working with physics, for example, the integer precision is going to go kind of out the window. All right, so be very careful about making assumptions about like integer precision, things like that. All right, while I was saying all that, anyone come up with any good questions about the project? No? Everyone's all set on it? All right, cool. So to date, we've mostly dealt with one scene, right, your adventure game scene. I've alluded to this notion of multiple scenes, of having a lobby sort of scene. And now something I'm going to say to myself, just to make sure that I did hit record. I did hit record. 9 times out of 10, I misremember hitting it, but then I forget about turning it off, which is a terrible thing. That's why I record the whole weekend. So anyway, so scenes, I want to talk a little bit more about those and how we get to the point where we're going to use multiple scenes and what really is a scene in terms of what how Unity treats scenes. And a lot of engines fall into the same category where a scene, we think of a scene as sort of like the levels in a game, or maybe even the rooms in a level, or some kind of grouping. So let's try to think about what a scene really is and how we manage scenes and what the implications there are. And then a few other persistent concepts. What I mean by persistent is the things that stick around for a while, and we want to control whether they're around or not, right? You want to save the high score. So from game to game, you keep the high score. Or you move from room to room, and the background music is playing, and you want the background music to keep playing as you go from scene to scene, that sort of thing. Imagine that. Or even you have certain things that you want just access to across your whole game. Things like your math library. It's certainly nice to be able to refer to math functions no matter where you are without instantiating special magic math operations and that sort of thing. So we talk a lot about this notion of things that are sort of persistent. That's going to be our theme for the day. All right? Okay. Now, one thing I want to mention first up, because this shows up in a couple of things, so this is more for your information, frequently asked questions. Just in case you see it, I'm not going to go into super depth on it. But for now, we've had just the start event in Unity, because that's a convenient point. We know when the scene starts, all the components that are on active objects in the scene, they wind up with their start function being called. And we only have one script in our game manager, so that's sort of our entry point for when you hit play in the game, right? Right. And we're not using the update function yet. We'll use update a lot more. That's when we really start having things happen in real time, and frame happens, a frame happens, a frame happens, that sort of thing. Now, in some of these slides, it's going to refer to this other thing called awake, another event called awake. I don't want to get into the specifics of why awake exists, but just know for now it is another type of event. It's called before start, and basically it's as the component is loaded into the scene along with its owner object, just like start is, but it just happens sooner. All right? First you awake, then you start. Just remember that for now, and later we'll talk about more the subtleties of that, more at a later time, right? So awake happens before start, but kind of looks like start for the most part. All right. So these persistent things, persistence, the things that stick around. All right. So you want to keep it for a while. It has some longer-term life than shooting a bullet or something like that. An object that happens and just goes away right away, and it's sort of temporary, ephemeral, whatever, however you want to refer to it. Things that kind of stick around. So let's talk about scenes, because, well, that's where kind of everything lives when your game is running. It lives within a scene, or it lives between the current scene and kind of the active state. We typically think of them as, you could have a lobby, that could be a scene. The stages of your game, maybe that's what you mean by a scene, or maybe the levels of the game, that's sort of what you mean by scene. It's sort of a fuzzy word when it comes to those. Maybe you have a config scene, a splash screen, an end scene, a death scene, whatever. It could be all sorts of different types of scenes, cut scenes, right? So we often think of them in terms of levels, stages, distinct kind of groupings of things. We're in some kind of state where the scene is happening, right? So a simple view of the world, a basic view of the world, would be to say, all right, a scene is a unique level in your game which contains the game's current environment, its objects, current objects, and its current menus, heads-up display, whatever it is. It's everything that's there. It's what you can see, the heads-up display, the canvas, and the stuff that's potentially in the game world, right? And this definition we can use kind of 90% of the time, but it's good to kind of really think about it in a bigger sense in just a moment, right? So the basic parts, you certainly all have worked within a scene at this point. You might have just accepted the sample scene. Maybe you renamed that sample scene, hopefully at least, or maybe you're just working inside sample scene, or maybe you created a new scene called adventure game. Maybe you went so far as to create a lobby scene as well. So you might have a couple of scenes kicking around, And you may have done it either by right-clicking in your assets folder and so on, or good old menus, right? File, save scene. We can open a scene, double-clicking on it in the assets folder, or file, open, select the scene there, and so on, right? They're just assets within our asset folder. But you might think to yourself, okay, well, what are these things? What are actually what's in the scene? What are the assets? Well, it's a hierarchy, it's a tree, it's got, a reference to a bunch of things. Here's going to be the game object, here's the canvas, here's whatever. They're all kind of referenced by that scene, right? So we create a new scene, we put objects into the scene. We hopefully give them descriptive names, just like any object, because we might want to refer to them. We might want to say, well, here's the lobby, here's the adventure game, here's shoot 'em up, here's whatever. But now, thinking for a moment a little bit of a higher conceptual level, scenes are really just a high-level hierarchical collection of game objects, right? Everything over there in that scene window in Unity there, we see a hierarchy. It's just game objects in there, their components on them and so on. But it's that hierarchy of game objects. So it's a collection of game objects. Now, what representation that takes, we're not going to worry, oh, is it an array? Is it a linked list? Is it a tree? Newsflash, it is, it looks like a hierarchy, so chances are it is a tree of some sort. We don't have to worry about that. We just have to know it's a collection. It has this hierarchy. It has some sort of base, and then it has, all the stuff that are in it, and maybe those have child objects, and so on, right? So we have that wonderful collection that forms our scene. So, like many other objects, it's handy to be able to say, instantiate one of these things, create one of these things, use one of these things, right? Use a scene. Primarily, we do that through something called the Scene Manager, which is kind of where all scenes live. It's not too different. Right? Remember when we did GameObject.find? Right? Probably all done that by now. We used a capital G, meaning we're asking something of the game object class there. Not any particular game object, but we're asking something of the game object class. And it turns out there is a Scene Manager class, right, that we can refer to, and we can ask for things about scenes as well, right? So the first, we have some scene that is loaded up the moment we hit the play button. When we package our game, it'd be nice to be able to say, well, what scene gets loaded when the game starts? Talk about that in just a minute. But we use these things to manage our scenes. We can do it from scripts. Typically, the action we're taking is we're loading a new scene, abandon the old scene, right? In with the new, out with the old. I went into a new room, therefore, I need a new scene. That's triggering that new scene gets loaded. You tear down everything, it ceases to exist, you're now in the next room. Imagine that, right? I left from one room to the other room, and the moment I cross that threshold, this room is entirely destroyed. Down to the ground. And the new scene somehow is built right up at that moment I'm walking through. Builds up that whole new scene. Yes?
When you say, would you say Scene Manager.load scene inside the script of the old scene?
Absolutely.
So that would end up
tearing down everything that we're currently on.
Because I tried that and it said that it couldn't watch it in the whole.
Okay, you might not have been able to load the new scene because it didn't know how to refer to the new scene, perhaps. Right? We'll get to that in 1 minute from now. So that's typically what's happening, right? We're just destroying every object that was in the old hierarchy. We're just blasting that old hierarchy away, loading in a whole new hierarchy. It calls all its awake and its start functions and all that, just bootstraps everything from scratch. You also typically use this when you restart a scene. You can do that. So say the player dies, you give them the option, you say, hey, you want to restart the game? Turns out you can just say, oh, reload the scene you're in. And it does the same thing. May not feel that way, but it tears down the whole scene, starts the whole scene up again. That's what's happening. Right? So it's usually this scene manager dot load scene that decides, what scene to load. The step A usually goes by, we have a scene name. That's why we want to name these things, good, come up with good names so we can refer to them. And that is just a string that references it. It's a pure string reference, human readable. It's all about us being able to understand what it is. So this is the one we typically see. And notice this note here, loading a new scene must be added to build settings. So at some point you might say to yourself, well, if there are multiple scenes, how does Unity know what those multiple scenes are? Is it every scene I've ever created? No. All right. At some point you say, despite this project having a dozen scenes, I only want to use these 3. Those are the ones I'm happy with. So it's nice that you can create these kind of scenes to try things out in and so on, and they can be part of your project. You can have a test scene, and then when you deploy, those don't exist anymore. It's just the ones you tell it out of the project. These are the ones that are important. All right. So in order to make sure that they are there and available when the game is really running, and it's a good practice to get in right away, is we are going to manage these, make sure that the project knows that these are scenes we want to ultimately deploy and we want to reference from other scenes. We need to access this build settings, especially because in this next line here you'll see scene manager load scene index, an integer, 0 through whatever number of scenes that you have that you might want to jump through. Maybe it's 5, maybe it's 100, who knows, right? But somehow it has to know, and you have to know, you have to agree upon this idea, well, what are those scenes that you're referring to? How do I get that index? It sounds a lot like a collection like we talked about the other day with lists and arrays and so on. So where does this list or array, where does that live? Did I create that? Well, yes, you do, but not in a script when you create that. And then you can also do things like, crazy ideas. You say, well, okay, let me ask the scene manager to get the currently active scene, get the index within the build manager of that scene. So this one works an awful lot like just saying reload the current scene, but you don't know what the current scene is. Maybe you don't know what the scene index is, or maybe you don't know the name of the scene that you're currently in. Sounds crazy, right? Why wouldn't you know? Well, maybe you're writing a script to be very generic because you want to use it in all sorts of different scenes. So you don't know, and you don't want to make the assumption that this script is only happening inside of the lobby. So you say, load scene, scene manager, get active scene, build index. And that'll just, whatever scene you're currently in, it'll know how to reload it. Right? Something to try. All right, so the build settings. So we have Unity over here. And you'll notice I'm on another scene here. I'm here in the adventure game scene. Or actually, I'm in the lobby scene here. All right, the lobby scene, which happens to have a button to go back to to go to the adventure game, and some text. Is that a question? Or? Yep.
You sort of do the whole idea with the build index and getting it to where you see.
I'm just about to get there. All right. So here I have a lobby scene. And then if I look, okay, here it is, living in this folder. But strangely enough, if I go up to Assets, I also have my adventure game. And it has scenes, and it has my adventure game scene in it. All right, so I have 2 scenes that I want to work with. And maybe I had another folder called Shoot 'em Up that has the Shoot 'em Up's main scene in it and so on. I want to be kind of careful. It's not good to have a main scene inside Shoot 'em Up and a main scene inside of the adventure game. I want to keep our names distinct. But then to your question about well, how do I refer to them? Where's that build index coming from? Where does that happen? So in here, in Unity, if we go to File, Build Settings, this is a project setting kind of thing. This is where we tell Unity what scenes are going to be important to this build, potentially. So when we go to actually give the game, we would deploy the game, these are the scenes that are going to be, that need to be there. Now, reason for this is that If I have a load scene function that just uses a string, that's not resolved until runtime, we say. So a lot of what happens in a script really doesn't happen until things are actually running. And Unity won't know exactly what scenes are going to be necessary just based on that. I mean, I guess they could get real crazy parse through, but they don't. So somehow you have to warn it ahead of time to say, oh, okay, I know I can dynamically load scenes, so therefore I need to warn you about the scenes that I might need. And that's what this is about. You see up at the top there, it says scenes in build. And the first one there is our adventure game scene. So I know that I can always refer to that one. And if I just did a build, I'm not going to build right now, whether it's WebGL or Windows, whatever. But if I did a build, that would be the default scene, the scene that we launched into when the game started. Right? That's the only one there. And it just so happens to be build index 0. Right? The build index of that scene is 0. Now, if I know I'm going to be referring to other scenes, so obviously in here, I might want to refer to the lobby. Now, once you are using Perforce, and I assume most of you are, you might see in here, you might not be able to add open scenes or drag and drop like I'm about to do. And that's because the project settings folder needs to be checked out from Perforce so you can make changes to it. So you may see a little button right here that says check out, right? And that's just saying, okay, I want to make changes to the project. Later on, make sure to check that back in. We'll really kind of reinforce all that on Friday just in case. But you may need to do that just in case. Be aware of that. So now, if everything is writable, the file is writable I want to work on, I can go and find the other scenes, and I want to get, let's see, that was scenes lobby. And I could drag it in here, or if it happened to be the scene that was open in the background, I could say add open scenes. And now that scene is part of the project, and now it's okay for me to say scene manager.load scene lobby, because it's going to know about it. I say scene manager load scene adventure game, because it knows about it. It also knows where it lives in the whole hierarchy, right? So it can take care of that. If I want the lobby to be the first scene in the game, I can drag that up here and put that first. Makes sense, right? When people go to the lobby first. So they go up there. They're in the lobby. And then, well, somehow we're going to have to make it possible. We're going to have to use some scripts to give them the action, the access, the ability to go from the lobby to the other scenes. Right? So as life goes on, we're going to be able to do all sorts of fun things. And we'll just, I'll give you an example of this sort of thing. Like say, I want to conceptualize my game. Yes? See right there, 0 and 1?
Oh.
Okay, so those are the indexes. So think of this sort of now, okay, it's kind of like an array. The 0th entry, the first entry, and so on. Right? So that's why it's an index into this list or array of scenes that I've now created in the Unity editor. Right? So as your games get more complex, you're probably going to have something at least like this. Right? There's going to be, think of it as a map now. Okay, we have the lobby. And there should be a way to go from the lobby to, say, the adventure game. All right? And maybe there's also a way to go from the lobby to, we'll call it Kaboom. Right? That'd be nice. So in the lobby, we put a button, another button, and we have some script in the lobby that has, it's a component on some object that just says, okay, the script here says, if you press this button, load scene, adventure game. You press this one, load scene, Kaboom. You can pass it indices. Remember those index, the numbers we said? You can actually use that as well. All right. So then we can start to think, well, how do we get back to the lobby? Right? If this game ends, you might want to think, all right, there should be some way to go like this, right? That would be kind of cool to be able to do. We probably want to do the same thing for this, right? So there should be another way to do that. So we might need some script that says load scene lobby. So maybe everywhere else they have this other script that they all share that happens to have that component in there. Or maybe we're even fancier than that. Yes? Excuse me? Remember, a script is a blueprint. It's a recipe, right? So once a script appears in your library, in your assets folder here, you can put that on any object you want. And you can put it any number of times that you want, right? Components, every object can have whatever components it needs, right? So the game manager script that we wrote, we could put that game manager in a dozen scenes if we wanted to. Now that would kind of imply that there's enough in common of those scenes that the game manager script that we created, which is a little bit on the specialized side, that's probably not a script we would wind up being usefully shared across a lot of different scenes. So that's why we want to start to, once we're done with the first project, the amount of functionality hopefully becomes a lot more modular, right? Our scripts should be, our components should be much more specialized. Right, so there'll be much more, there probably a fair number more components, scripts, but they should all also be, we're going to get well-designed ones. Be careful about, what is in each of those components, that sort of thing. Right. So just to keep going through our model here, we might say, well, all right, the adventure game also needs to have a win and a lose scene, right? Might have that. And then each one of those might say, well, do you want to restart the game, the adventure game, or do you want to go back to the lobby? And the lose needs to do that as well, right? So the lose needs some way to get back there, and the lose needs some way to go back to the lobby. All right, so you start to have a map of your hierarchy of your game to figure out, what goes where, what scenes. Even in the case of these sort of simple ones, where we're just saying, okay, the win condition, the lose condition, the advanced. Is there maybe here is a welcome screen. So even in a relatively simple case, we have 1, 2, 3, 4, 5 scenes. Right, in a game that seems pretty trivial, even if you wanted to go that far. If you want to go even simpler, you just say, well, there's actually just a text. There's just a text box that you show the welcome on, and then you change the text. Probably done that in your game. Or you just printed out something. You won, and you're cool with that. That's fine. But as we get more sophisticated, we want to do things like this. All right. So scene management is important to get. It's important to understand. Even at this, what I call the basic level, where all we're doing is loading a new scene, tearing down what was there, loading the new scene. Right? We have to figure out, this lose and restart, or lose and go back here, or is there, you have multiple lives in the game, and you only go to the win or lose condition. You only go to lose after you lose 5 lives, but somehow, maybe you've got some kind of condition where you're allowed to retry in there. Yes?
All those conditions, win, lose, and etc., those are all in the current Lumen script. And if you win or you lose, if that gets triggered, then you end up going to either the win scene or the lose scene.
Right. All the functionality currently has to be in the game manager script because that's the only place we have events happening. Right. So that's where our buttons are. And then from there, it would decide to go to some other scene, and that other scene would have to have, this is where this scene here, the win scene, the lose scene, the welcome scene, the lobby scene, chances are, they can't refer to the game manager that lives here, right? So each one of these scenes has to have at least one object in there with a script on it that has the ability to tell me where to go and be plugged into buttons and so on. Right? Can we kind of get that? Right? So if we're only here, if we're only in this one thing, one script is okay. But the question is, in this scene, we have a new game object, which is probably not our game manager, because the game manager is too complicated for that. The lose scene, maybe that is a simple one that we can share across. This win, lose, welcome, lobby. We have, one simple scene manager for this whole branch, perhaps. That the only purpose of that is to be able to move us from scene to scene. All right. We'll focus on the concepts and then do some implementation, and hopefully makes sense as we kind of go from that. All right, so the main thing for now, the one thing to try, is this notion of, okay, after everything happens, whether you win, lose, and you're telling the player that, you ask them, do you want to start over? So your first use of load a scene should just be load the current scene again. Reference it by name, reload the current scene. Try that one. The one after that, if you feel like getting fancy and you want to have a win and lose and so on, that's cool as well. But having a simple lobby that says, okay, it has the lobby manager, right? We'll have a lobby manager screen for this. This should actually probably have the adventure manager, and this will have the kaboom manager, and this will have a game manager for each of them, because they'll probably have unique enough functions that we're not just going to use game manager everywhere. So you might have a lobby manager and a game manager. The lobby manager just needs to know four simple functions, how to get to each of the children scenes using something simple like this. All right. Now, I'd like to reiterate this just for now, because remember, we're always just kind of going up and down hierarchies. We already know about the game object hierarchy, and then we're getting game objects. We're finding game objects by talking to the game object class, just like we're finding potentially scenes we can switch to by referring to the scene manager. And then once we have a game object, right, so this is lowercase game object means it's a particular game object. Once we have that, we can get components from it and find the scripts do different things on them and so on. We're going to start to see some fancier functions as we go. Things like, well, get me all of the components that this object has of this type. So imagine we had 4 audio sources on one object, which you might by now. And you wanted to change the overall volume level. You might say, game object, get components that are audio sources, and it returns an array. And then you do a for each in that array, and you set the volumes of all of those things scaled according to the slider. Right? So if you needed to look at multiple components, you could use something like this. You may also have, one of those hierarchies we talked about, where you have a game object, and then you have another child game object, because I have the enemy has a body, and it has arms, and the arms have hands, and the hands have fingers, and so on. And it turns out that the guns are actually finger guns, and so I don't have a reference to the fingers, but I want to ask this hierarchy, give me the finger gun component. So I could say, get component in children. It'll go through that whole hierarchy and find the finger gun, the first finger gun it encounters. In this case, since it's just get component, if I get components in children, it'd find both finger guns. I forget the character in Eternals, right? Has the finger guns. So we get more sophisticated that way. And as you get really sophisticated, so we have the finger guns now, we have different types of weapons. So we have different objects that maybe they have these components, and they're the weapon objects. And the weapon objects might have audio components. When I fire that weapon, I need to say, oh, play the sound. Right? You've probably all seen, you've gotten referred to a game object's audio source and said play. Right? Or you refer to the audio source and you set its volume. Right? You did that. Maybe as part of doing that, you went through the whole process and you hit play and it said, component not found, or null reference found, or you didn't, that wasn't there yet. So sometimes it's just a matter of simply fixing that bug, or sometimes that's just kind of the way it works. Maybe you have a silent weapon that does not have an audio source, and you have other weapons that do have audio sources. So you can't just assume that every one of these components is available. Or you have to somehow, you could go through the process and say, oh, let me check. is, get that component. If that component is null, don't do it. If I get that component and it's true and it's not null, I do that thing. So that's so common that we have a special function called try get component. So you can say, oh, let me try to get the audio component of this object, for example. And now it will return true or false if it found an object of that type. And then we use the out parameter, or the out keyword here, to pass it back. Right? So remember we talked about out and ref last time. So this is one of those examples, as I threatened we'd start seeing those things. Right? So the API is going to get more sophisticated, hopefully with the intent that things become more readable, and common things that we do over and over again, patterns that we fall into, habits that we fall into, are sort of embedded in this API. We'll talk more about this notion of falling into patterns and good behaviors and best practices and so on in a second. Now, that was just the basic. I wanted to reinforce objects and kind of going up and down hierarchies, and scenes. They have hierarchies of objects. So we have scene, object, component. So you might be saying to yourself, well, if this is the scene, and the scene has lots of objects, and the objects have lots of components, what about up here? What could have scenes in it? Well, my build I just set up has multiple scenes in it, didn't it? Right? So it had multiple scenes in there. That's one thing. But could I have something that had multiple scenes at the same time, right, within my game? So you can. Why would you want to anyone have any idea why would you want to have multiple scenes active at the same time?
What if it's kind of like, and like in this Undertale, it's like when you go away from a room, and then you go all the way and you go back, and then the person wants to go back immediately after leaving the room. They want to go back to the scene as it was when they left, so you want to keep that scene running?
Well, not what I was going for, but that's more just like if you wanted to use something to re-trigger the load of a scene, that would be something you just do with load scene.
Well, say this room is a scene, and say the computer room is another scene. When I walk out of that door, I don't want to have to wait like a half minute for the computer room to come up.
Right, right. So anytime you have some sort of hierarchy, if you have something as hopefully obvious in the case where, well, we have even this going on, right? Well, no, this isn't as good an example. Let me draw a much better example. Say I have a castle, or I have a village, or something like that. Something that is complex, fairly complex. Dozens of rooms, thousands of rooms, potentially. And I start off in this main room. I have a main room that has a certain number of doors in it, right? There's all these doors. And each one of those rooms contains 100 enemies that need to be doing stuff. They're taking up lots of time, going to be doing all sorts of cycles and things like that. And then each one of these rooms here has a number of other doors that has lots of enemies doing lots and lots of things and so on. Right? So potentially the number of components escalates rapidly. Right? So I can only have a finite number of resources. I can only have a finite amount of things in the computer at once. At some point, it's going to get to that point, especially if we have complex AI going on or lots of rendering going on, right? Welcome to Nanite and Lumen and so on, right? How do I manage this sort of thing? Sort of, kind of. So I say, well, wouldn't it be nice to say, this is what's currently loaded. I'm in this current room currently. The player is here, and depending on how fast the system is, I put a hitbox or a radius here, 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 something like that. And I say, the moment that box is hit, I load this room. So I have to give myself enough time. I can design appropriately, and it's going to depend. Maybe you have instead of just literally that changing that quick. You've probably all done the loading, the traveling scene where it takes a little bit of time and you're kind of seeing what's going on, but eventually you get there and voila, the whole castle reveals itself to you as you turn the corner. So the moment I get here, I say, okay, it'd be cool to be able to load this scene in response to this, but obviously I can't get rid of this room yet because I'm currently in that room. But I want this room to be ready as I start to go into that room. All right. So a lot fancier is this idea of using this to our advantage, to have basically scenes that have other scenes in them, that have children's scenes. All right, so not only a hierarchy of objects in there, but you can put other scenes into scenes. To do that, we use something called load scene mode additive. So if we want to load a new scene, in addition to everything we currently have running, we additively load the current scene, or we additively load the next scene. And at some point, we might want to say, well, unload scene async, which means drop whatever scene that was, right? The moment we're in this room, or maybe we get so far as to be in this room, we say, all right, don't need that anymore. Drop it, get rid of it. Okay? So we have this notion of loading and unloading. The whole universe sort of exists as we walk into it. I mean, how many of you have played Minecraft and suddenly you crossed the threshold and you saw the whole world was sort of like, all right, building some more, right? So loading a new scene, building that sort of thing.
Kind of like on a scene, and then you have two scenes inside of it. And if you want to create a new scene, you just say the scene manager of that parent scene dot load scene, and then you do the scene name, and then load scene load dot, and then that'll add to the loading scene inside of the parent scene.
Yes. Yeah, I think you got it. Okay, so it's the notion of like just adding objects that are a full collection of objects, a full scene to the current scene, right? Now, the cool thing here, you'll notice this async, and this will show up other versions as well. What async means, asynchronous. We've all had an asynchronous class or two, I think, at this point. Have you, basically not synchronized in time is what that means. So when you say unload scene async or load scene async, it means kick off that loading, but I'm not going to wait until you've actually loaded it. Right? So the moment you cross this threshold, you don't want to stop everything and wait for that scene to be loaded because you've designed in enough travel time to get through this corridor to this door, which is where the scene really is, maybe. Right? So you load the async here, gives you enough time. You get to this door, you make sure when you get there that you want to check is loaded. Maybe you do that because you want to make sure the player actually has all those other objects in the scene. But that'll tell you then, you have the next scene or that additional scene loaded. Right? So async allows you to kind of kick these things off, but allow gameplay to keep going. You're not waiting for that to happen. Right? It's very handy to create these kind of seamless experiences moving from scene to scene to scene. You may or may not ever get there in terms of implementing this stuff in this class. It's definitely more a fancier, advanced feature. Can get through all our designs without doing that, but it's a cool one to have, and it has other uses as well. It doesn't necessarily have to fall into this category. You can do things like have all of your enemies in a scene and have your room in another scene that are all designed the same way. And all sorts of elements, the flames and the candles are burning and the music is playing in the background and so on and so on. And that scene is just loading away. And you say load scene, all the enemies show up because you loaded them asynchronously into your current scene. None of the stuff that's already there is affected because that's already there. Right? So it doesn't have to be literally a new room, a new level, or anything like that. It is just, like I said before, a collection of objects that you build as a scene that you can then bring into the other scene, however you need to. Okay? Is that heads a spinning? Makes sense? Right? So say you had an army that you suddenly wanted to bring into the whole scene, one way of doing it. There's some other things that we have as well. called prefabs we'll talk about later, a little bit more lower level for doing things where we want to build up lots of enemies and so on, but this is the scene way of doing it, okay? So on your own now, grab this slide, try some of these things. All right, think about the structure that I just talked about. Create a few simple scenes. Maybe you want to just block out your project. Block out your project for the year or for the semester, right? Say, okay, it's time. I have my adventure game. Let me put a lobby scene. Let me put a shoot 'em up scene. Let me put a platformer scene. Let me put a kaboom scene or apple picker scene. Go ahead, create those. Just empty scenes, whatever, and just put them there in your asset folder. Maybe startup, maybe gameplay, maybe good, bad, end scenes. Doesn't hurt to have multiple scenes in there. Try to keep them reasonably organized, and figure this out. Startup should lead to gameplay. Gameplay should lead to either a good or bad ending. Maybe both ends should go back to startup or try again. Right? So it's all about trying to figure out back and forth. Figure out how many scripts do you really need to do this. All right? In theory, you could have just one scene manager that had references to everything, and you could have, a version of the right function that moved you to a particular scene, and you just use that same component in all of your, one version of that or one instance of that component in every scene that you had. You could potentially do that. Write that script that can be used to navigate from one scene to another when a certain input happens. Click a button, maybe eventually press keys, and so on. Create an object in the first scene, attach the navigation script to it, boom. Make sure the object will persist across all scenes. Now this is a bit more of a challenge. Yes? What's what? Are you reading 3 slides ahead, or?
Oh, no, it says right there.
Okay, we'll get there, all right? Some helpful code snippets, we'll get there, all right? It's going to be there. That's a big slide on it, okay. Trust me. You got to trust me here, all right? Okay, so there's going to be helpful code snippets, right? We have scene manager, we have load scene, and yes, there's going to be one called don't destroy on load, which is complex enough to need a couple of slides and moments on its own, right? This idea that you want to have objects persisting across scenes. Somehow, either one of two situations has to happen. To persist across all the scenes, we either have to have one scene that has the object in it, and then anything else winds up being loaded and unloaded and loaded, but that master scene contains that object. That's possible, right? If you said, okay, here's master scene, and that has the background music or the player, and only one of those exists, and the moment you start the game, you start there, and you never go back to there because that's where all your initialization happened. It only happened once, so one of them exists, and then you move on to other scenes, or you load in other scenes asynchronously, and maybe you load and unload all those other scenes, and everything's good. But you have that master scene that then anything that's in there is always there because other things are just loaded on top of it. That can be a little messy and a little bit too formal if maybe you just want to have something as simple as having, say, the background music play over and not get reloaded. Maybe the background music is persistent. Or you run situations where you're going to make sure that there will only ever be one copy of some object in your game. So if you had something where you weren't loading things asynchronously, but you're literally tearing all this down and moving on to the next one, the question before, I said, okay, I move over here, this gets torn down, and here, potentially the problem is, if the player was part of this scene, and the player moves across this boundary, the player gets torn down too, all right, because the player is part of that scene. If there was background music that you wanted to seamlessly play as you walked from this room into the corridor, you have a problem, because the background music is on a component in this scene that gets torn down that no longer exists the moment you move to the new scene. All right, so you potentially have that problem. So you could get into complex scene management where everything is an asynchronous scene and you're always additively loading things. I'd argue that that's more complicated. The simpler version is if you know, for example, you have just the player game object that you want to keep. We have something called don't destroy on load. So whenever you load a new scene, this particular object doesn't get destroyed, right? I'm allowed to exist as I walk through the doorway. That I'm not going to get destroyed because the world, the scene I was instantiated in, the scene I started off in, doesn't go away. Of course, the world does, but I don't. So we have this don't destroy on load for that. Okay, here we are. This is the advanced topic, right? Persistent game objects. A game object you want to keep around from scene to scene to scene, even if the entire scene was loaded and unloaded, right? So making a game object, for example, background music, persist across scenes. Don't destroy on load is a magic function, and a function you can use to preserve the specified object and any of its children and their components, of course, right? We're not using this on a component level, we're using this on a game object level. So something like the player, could be the game manager, could be whatever, right? And the simplest way to do that is imagine, okay, we've got the audio manager, the game manager, the player, whatever. We have a component on there that has this simple script. And all it does is says, okay, game object, when the component wakes up, boom, don't destroy on load this game object. This is a special word inside of our scripts. Like most object-oriented languages, it's nice to have some way to refer to the class, the instance of the class that we're in here. So this is an audio manager, which should be derived from a mono behavior, but it wasn't. Sorry, my code is too simplified here. So if I said this, I can refer to the built-in members and methods and so on, like the game object that this component lives on. Notice this is, lowercase g here, meaning, okay, it's the game object variable that happens to be pointed to from this component. So it's a nice way to, we've been looking from game object down to component, done that quite a few times, given a game object, find a component. But we have a way to look back up as well, a convenient way to say, from this component, use this .game object, we can figure out what game object we're on. Yeah?
So then how would you, I'm still thinking how you would then access that game object on another script or another slide?
You can't go, you have to be careful when you're using something like gameObject.find or something like that, that's going to be looking through all of the active game objects, so the scenes have to be loaded. You can't access a game object on a scene that's not loaded. Okay? But normally to get any particular game object in the active scene, you're going to use gameObject.find, right? If you somehow, normally you're going to be finding another game object and finding components on that game object, and then from that you could find the game object that component was on. You can go up and down and the trees all sorts of different ways. But important part here is how to reference the game object that this component is on so that we can tell the system not to destroy it when a scene is unloaded, right? So common pattern, common practice, we're going to start using this pattern word in sort of a special way. Imagine you have a splash screen or loading screen before your start scene. You have all your persistent objects in there, our master that we kind of alluded to here, right? Our master scene, right? And we don't want to have this situation I described before. We had the master scene, then asynchronously or additively loaded everything. Instead, we just said, okay, master scene, set up the background music, and immediately tear yourself down and send me to the lobby. Right? So I'm never going to go back to the master scene because that's where I set up all my load once, my load, don't destroy on load objects, right? Because I want them to play their sounds continuously, and off they go. So why am I doing this? Why wouldn't I just create them in the lobby, right? I mean, if I create them here, what does it matter if I create them here or create them in here? And let's just draw we have our adventure game, our win, and then we had the situation where we went back to the lobby, right? I want to just have that there for reference. Pardon my additive scene loading on the whiteboard here. Okay. So here's our scenario. I create an audio source here. In my master scene, I say don't destroy on load, So it gets created and it exists here. I go to the lobby, it doesn't get destroyed, it keeps playing. I go over here, it doesn't get destroyed, it keeps playing. And so on, it comes back here, it doesn't get destroyed, it keeps playing. All right, things are good. I only have one of them. That's exactly what I wanted. Now, if instead I said, okay, I don't want to deal, this seems weird, this kind of vestigial organ over here. Why don't I just put my background music in here, and I'll create my object there, and I'll use the same don't destroy on load there, right? Why do I have to deal with that? The problem occurs because when you declare something don't destroy on load, it doesn't imply don't load on load. Right? It's only saying don't destroy on load. So what happens if the scene already has one of those, already has a background music, already has a player? What if you're reloading the same scene? Right? It might be something as simple as adventure game restarting. You certainly don't want to have another player within the same scene or more background music in the same scene. That would be bad. So you have to be careful about that. So it's kind of a bit like musical chairs, right? We should only have one background music kind of playing. We have this one thing we want to have going on. And the problem is we reload the scene and it's like introducing another player in. Are they going to behave nicely? Probably not. They're going to clash, not going to work out. We load the scene again, another one comes in, but we still have that one way of consuming the audio, right? We have lots of audio players going on, but we create this kind of chaos because we only want to have, one background song playing, not 3 copies of it playing. How crazy is that? All right. The problem with don't destroy on load is that sometimes you only want one background music player. Good example of that, right? You don't want suddenly 2 players in the game fighting over the joystick or something, kind of weird things like that. I mean, by players, I mean player characters in the game. All right, so let's think about this musical chairs analogy here. Somehow, I want my game objects to respect the fact that there's only one chair. And if I try to create another game object, or I try to go to the lobby again, and the lobby normally says, all right, let's boot up and here comes another player. That new player enters the scene. We want that player to say, whoa, there's already somebody in that chair. I'm going to bow out. I'm not going to create chaos. So we have our first, what we call, our first official programming pattern. So this is a soft introduction, soft launch for many of you as you start taking other courses. I forget if it's PSOS or Fundamentals of Computing Science or something, when they start talking about programming patterns, and there's books dedicated to this, and there's versions that are dedicated to the traditional programming, and the group of engineers, the Gang of 6, who have like the Bible of these things. And there's also a book by Scott Nystrom, another developer, who specifically wrote a book. It's a really good one, Game Programming Patterns, that talks about programming patterns that are kind of specific to games, or things that show up, kind of. It's always kind of fuzzy, sort of whatever, behind this notion of a programming pattern. And the first one we're going to talk about is the singleton. Right? So before you start talking about singletons, I want to address what is this notion of programming patterns, and why is it good to have them? What are we, why should we think about these things? So in software engineering, not just in computer science, but in software, kind of the engineering side, a software design pattern is a general, reusable solution to a commonly occurring problem within some given context in software design, right? So it's sort of a similar problem that could benefit from a similar approach, but probably not exactly the same approach, but it's sort of like an algorithm. Maybe it's an algorithm, maybe it's just a structure. We can't say, it's hard to put your finger exactly on it sometimes. But in a general sense, imagine you've got a common approach to a common problem. And it's happened enough so that we've sort of all agreed that, yeah, this is one that shows up a lot of the time, like in the case of the singleton we'll talk more about. Right? It's not necessarily a carved-in-stone finished design that can be transformed directly into source or machine code until you get specific enough. So I'm going to give you an example that is actually in source code for addressing singleton components or singleton objects in Unity. Would it fit every solution? Probably not. Will it fit a lot of them? Yeah, it does. So this other part here is a little bit fuzzy. But you can think of it as a description or a template of how to solve a problem that can be used in many different situations. So this notion of the musical chair or the single instance or the single slot, that's kind of the general concept, that I want to have somehow this entity that enforces this uniqueness. So design patterns are therefore formalized best practices, right? We know the approach, we know it works, so it becomes a best practice that the programmer can use to solve common problems when designing an application or system, right? They're the templates for solutions, right? The kind of thing that, you don't want to reinvent the wheel. It's the wheel. Not every wheel is the same, but, the concept of the wheel is a pattern. We have a wheel and an axle and so on. We're going to bring that solution to the problem of creating a vehicle. All right. So Singletons is one of these things. Software engineering, the Singleton pattern, it goes certainly, it's not unique to game programming by any means, but we do see it a lot. It is a software design pattern that restricts the instantiation of a class to one single instance, right? So there's only going to be one of that object. We want to prevent anyone else, or we want to have the other objects prevent themselves from being instantiated in the first place, right? This is useful when exactly one object is needed to maybe coordinate actions across the system, or maybe it's the player, the game manager. And the term singleton comes from a mathematical concept of, the singleton. It can only have one value, it can only be one thing, it only exists 1, 1, 1, 1, 1, right? So in our musical chairs problem, after the chair is occupied, meaning we have our singleton, don't let anyone else join the game of musical chairs, right? Better than having the chaos. Nobody fights over the chair. Somehow that new one that's about to spring into existence checks. Says, okay, is there room for me there? If not, go away. You could potentially expand this beyond singletons. You could say, well, there's room for 2. All right, I'm allowed 2 and no more. That's possible as well, but the basic practice is singletons here. Now, sure enough, this is a bit of C# code for Unity that is a fairly generic and useful implementation of singletons. Right? Singleton pattern, one implementation, particularly useful if you do want to use don't destroy on load. Okay? Now there's a few new keywords in here. I mentioned this already. We're going to talk more about this static keyword. You have to know that's kind of special as well, especially in the case of thinking about what is persistent, what is unique, what is, only one of that sort of thing. Well, I have a few slides for that, so don't worry too much just yet. But the idea is that we basically, somehow we have to say there's one chair in our musical chairs. So we set up a chair, and we call that chair instance. It's underscore instance. It's a private reference that's private to this class in this case. I'll go one step further, and just in case anyone else wants to look at it, I'm going to put a public interface to that instance, making it a property. I put a getter for that private variable, so it is now officially capital I instance there is a property of my class. Right? That's a little extra, just extra panache, feeling generous. We're not going to actually even use that in here, but it's okay. Private static singleton instance. That's the important one. That's the chair. We have to figure out, is anyone sitting in the chair? If not, I want to sit in the chair. So we have our awake function. So awake is part of the class, and awake happens before start. So it's the earliest moment in which, the earliest event in which we can run some code in response to Unity kind of kicking us off. That's the idea behind awake. So awake comes along and it says, all right, let me look. Let me see. If underscore instance does not equal null, meaning somebody is sitting in the chair, however, I see someone sitting in the chair and I say, oh, and instance does not equal this. So what does that mean? Anyone want to hesitate to guess?
So like if underscore instance, it checks if the instance variable is not equal to whatever it's looking at, like inside I don't know how to put it, inside the class.
The current instance of the class, right? So I'm the one walking in the room. I'm the one playing musical chairs. So I look at the chair and I see, oh, someone's sitting in the chair. Am I the one sitting in the chair? That's exactly what this is asking, because you want to be careful. Maybe through just the course of how things are being loaded and so on, maybe this gets called again from whatever mechanism. This is, being careful. You don't want to destroy yourself if you're the one sitting in the chair, right? You don't want to jump out of the chair and knock yourself out because that's what it looked like, right? So I want to be careful of that. That's what's happening here, and saying, okay, if the chair is not empty and I'm not the one sitting in the chair, this object that I'm currently working in is not the one in the chair, therefore then it is safe to go ahead and destroy the object that is trying to awaken at this point, right? Prevent itself from coming into existence. Yes?
The object that you're checking is a singleton object?
No. Well, the component I'm working on is everything within that component is all contained within this. It is a singleton, right? I've defined it as a singleton. The singleton itself doesn't exist as a class or as a variable type or anything like that. I'm actually defining it here. I could have named it Bob. I could have said public class Bob, and this would all still work. There would just be the private static Bob, public static Bob. These would all be references to there. That's why a singleton, or a pattern as we refer to it, isn't really a feature of a language or something as carved in stone as that. It's a practice, right? So I've created this structure, this class, which does have a reference to itself because it has to know. It has to have some way of saying, okay, where's the chair, right? So I'll have to explain in a moment a little bit more about static and why this works. Normally, well, let's just finish through here. So if nobody's in the chair, then therefore I can sit in the chair. That's what's saying here. Instance, this didn't happen, so therefore I'm the one, I can sit in the chair. Yes?
Oh, so instance has already been defined as some object that you're checking to see. Would instance be the thing that you're passing into the new scene?
The instance refers to this component. So it may be the one that's going into the new scene. It may be, instance at this point. Let me get through static. Okay, so the instance is a reference to that one chair. Now, so this is a challenge. Maybe this is what's getting you at the moment, is this notion of the static up here, right? If something isn't static, like if I didn't have static in front of that, you would think, all right, these are all object or instance variables, instance methods, instance properties. So every instance has its own version of this. So how could they all know? Why isn't every player, doesn't it come with its own chair to sit in, right? That's the problem. So this notion of static, right? Static is basically a member variable or method modifier that indicates that you can only have a single occurrence within the class which is shared across all instances of the class. So I might have 15 game objects that each have a singleton component on them, but all 15 of those singleton components, they don't have their own underscore instance. There's a static one that belongs to the whole class, right? So instance here is important because it's referring to that one version. There aren't 15 of them, even though there are 15 components on 15 objects, right? That's the important part there, right? A member variable or method modifier indicating a single occurrence within the class is shared across all instances of the class, right? So there is nothing within, if there's a static method or a static property, there can't be anything in there, in that piece of code, that is referenced across multiple objects and so on. It has to be entirely unique, entirely one of them. All right, so here's a little bit more explanation of this. Handy reference to the current instance of the class we are working within. When we're in a component, this refers to the instance of that component. You can think of it as an easy way then to figure out, okay, what other things refer to this component, like this game object referring to the game object that the current component belongs to, right? So statics are pretty powerful, right? Just get the idea, let it sink in that when we have a static, something that's static to a class, it's shared across the entire class as opposed to any other methods or variables or anything that's in the class which are created on an instance level, so you have multiple of them, right? If you have a component, an audio source component on every game object, you have 15 game objects, you're going to have 15 audio components. But if that audio component has some static field on it, then they're all 15 are going to share that one version of that. If one of them changes it, they all see the change, right? That's the important part. Okay. Let that sink in a bit. Now we'll do something a little bit easier, hopefully easier to kind of wrap our brains around. Let that stew for a while. Okay, player preferences, player prefs, also known as saving the simple stuff, right? So saving simple stuff, simple things like ints, floats, and strings, okay? And simple by meaning, just a few, you have one int that tells you the high score of the game, right? That's the classic one we like to see, high score of the game. Other things you might want to put in player preferences, what does player preferences imply to you? Some other data. Anyone? Eric? The volume, right? Overall volume, you want to set where that is. Right? So the next time you go play the game, the volume is set to what it was. Anybody else? Somebody else over here. Yeah. Sensitivity, the joystick configuration, is it inverted, not inverted, what are the key bindings? Okay, relatively reasonable kind of stuff, right? That sort of thing. Player preferences. Not the entire state of the game, not where every enemy is, not what the AI has internally going on, all that sort of stuff. Certainly not that. Right? Player preferences used to store and access simple data usually across play sessions. You can kind of, I wouldn't say violate this, but even, you have to think of player preferences, the moment you save it, it saves it as part of the project, somewhere on the hard drive, most likely, or the SSD, whatever, the persistent data store. Right? So the player prefs wind up being put somewhere into persistent data store, so next time you ask for it, it's still going to be there, even if the game was shut down. In a pinch, you can even do things like when you move from one scene to another scene or later on in the game or something, you're not sure, because everything in this scene got destroyed, and you reload it over here, and you still want to figure out the high score, but you didn't want to go through all the trouble of creating yet other crazy game object things or whatever. You can just say, well, okay, let me read the high score again, and it'll still be there, right? So sometimes you might use this not just across play sessions, but across any event that might cause, kind of the system to be torn down because a scene ended, for example. So it's a quick and convenient way to basically serialize and save limited data. So what serialization is, just in a nutshell, I won't get into super depth on it for now, but we talked about, when you see serialized field, sometimes we said that so that the Unity editor would be able to see it as an alternative to declaring something to be public. But what serialized really means is turn it into some condensed version, not necessarily compressed, but just the facts that are necessary for this sort of thing, right? So it's saying, all right, let me, if I have a structure or a game object that has lots of things, its position in the world and all kinds of, but the important part is the ID, right? So I would serialize it and scrunch it down to just, not the pointers and so, but just the important data. That would be serializing the data that was associated with that object. So you come up with the bare essence of it, and that's what gets saved somewhere, right? So normally when we save stuff, we go through this serialization process, but it's usually just part of saving stuff, right? Serialization is getting it ready to be saved. So we serialize a field in our script, it's getting it ready for Unity to handle it for us. So quick and easy way to serialize limited data. Don't use it to serialize entire game state, where every monster is, how hungry they are, how many hit points, everything in the whole thing. Don't do that. It's not very performance oriented. It's not meant for that. Use the player prefs keyword. That's the library this all belongs to. So just like Scene Manager, just like Vector 2, just like other things. It works by using a string as a key that is bound to a particular bit of information that you use to retrieve it. What does that sound like? You have a key that you use then to reference some information. Somebody else? Yes? Sounds a lot like a dictionary, right? So you have a key and a value. You have a key-value pair. And in this case, in case of player preferences, the key is always a string. The value has to be an int, a float, or a bool, right? You have only certain things that you can use. So imagine you have the key high score. You want to use that to save the top score as an integer, which then you can later retrieve. So you use that high score key again. You ask for it, and you would get it back, right? So you don't have to necessarily say using Unity engine, blah, blah, blah. It's just part of the standard. And the class it belongs to is player pref. So we can say player prefs dot delete key. We can delete something from the dictionary, from the database. Has key, you can check. Did you already save one of those? Right? Do you already have a high score? So in a really pedantic way, we could say, oh, well, make sure, check the high score, check it exists before you go and try to use it. Right? You shouldn't just try to retrieve it because maybe it doesn't exist already. Well, it turns out you can because that's enough of a practice that Unity decided to build in some things to provide a safety net for that. So you'll see here this playerprefs.setFloat, playerprefs.setInt, playerprefs.setString, your three main playerpref setting functions. Set the given key to hold the given value, and if the key does not already exist, create it. Otherwise, if it does exist, overwrite the value, right? So you can't just keep adding high score. You can only have one high score value, right? These aren't arrays. These aren't lists. They're just simple. That's why you would want to serialize every enemy in the game.
When you say set or set section, you can only do that to keys that hold values that have like float into strict. But you can only use set in for a key that has a value that's int.
If you use set int, it would be for ints. If you use set float, it would set it to a floating point value. So it's in the actual name of the function what the type is going to be. Okay?
So you don't need, so like if you try to set the dictionary.
If you set an entry, if you say set int and you pass it 3.4, you can't do that. You have to. It will give you an error. It'll just save. It'll lop off the 0.4 part. And it'll just save the integer portion of that. Right. So get float, get int, get string. That gets the value back. Retrieves the value associated with that key. If the key doesn't exist, it will either return nothing. So if you said this, right, get int high score, it'd be null or just 0 in that case. Or you can specify a default value if you've defined it as this second argument. So you might want to say, well, the high score, I don't ever want the high score to be less than 100. So even if no high score is already set, I try to read in the high score, and I'm going to get 100. Right? The nice thing about that is it does make this has key and so on a little bit unnecessary because we don't have to check if it already exists unless you wanted to do something where the default value isn't going to cut it for you. Yes?
If you do delete key, does it return the value that you delete, or is it void?
Just for deletion. You'd want to do retrieve it and then delete it. Okay. So here's a overly explicit example where this one actually does go through the extra step of saying, all right, first let me check, does that key exist by checking has key. If it doesn't already exist, it decides, well, all right, let me write the default high score into that entry. Really kind of unnecessary if this next line, instead of just being get int high score, if instead we had used get int high score, default high score, that whole first bit wouldn't have been necessary. But to show how it works, that's how it works, right? So it checks, does it exist? If it doesn't exist, go ahead and write one, just in case. And then it says, all right, let me read in whatever the high score is, and I'm going to put it in the text of some object on the screen. This is a little bit of a fancier way to use to form strings as part of this assignment here. We haven't really seen that before. I'll leave it there as an example of ways, basically, instead of saying this plus this plus this plus this, when we want to insert our variables into strings, you can use the $sign to indicate that it is a formatted string, and it will replace the curly brace current score curly brace with the variable there, and the curly brace high score curly brace with the actual variable high score there. So it's a convenient way to format your strings. You'll see this thing kind of show up. All right, and then the end of the game, that happened in start, and then maybe at the end of the game, take your pick how the end of the game occurs. You might say, well, all right, is the player's current high score higher than the high score, or the last high score that we had? If so, go ahead and write it. So for next time it's available. Whether you wait till the end of the game or every time the player beats the high score, like most arcade games, the moment you pass the high score, you indicate that. So maybe you want to save it right away and do something so the player feels better about the fact they just earned the high score and they're not lost. Up to you. But you can wait till the end, or you can interactively change it all the time. Careful of overhead and that kind of thing. All right. So, talked about libraries here and there. So let's be more specific about libraries and kind of get a real feel to what they're doing and how they are different and the same to a lot of stuff, right? We've been doing a lot of things, and it turns out everything is based on everything else. So libraries are basically static classes that contain static functions. So now we sort of understand what static is about, which hopefully makes libraries themselves make a little bit more sense. So libraries are classes with member functions that you can invoke without instantiating an object of that class, right? You don't have to have a math object to actually call your math functions. You don't have to have a vector2 to actually call vector2.distance. Well, you probably do, but you're not referring to a certain instance of it. You don't have to have a random number in order to get a random number, right? We just refer to the random library or the math library because those are static classes. We only have one of them. We only have one absolute value function because it doesn't depend on anything. It doesn't have to have some store around there, that variables that it uses that need to persist and so on, right? So they are there. They don't belong to any particular component, any instance. They just exist and are available. So library classes don't need to appear within a scene as a component or as an object in order to call them. They are just there, right? You should remember mathf.clamp, for example. This capital implies, yep, we're talking about a class here. And then there's some function within the class, and it turns out that's a static method of a static class, right? Sometimes classes will have static methods that feel a little bit more like library functions. So vectors are kind of an interesting example, strings as well, where we did say vector2.distance, or we could say string.compare. We're not referring to a particular string, but then we're forming an operation on things that normally we do create instances of. We do normally create vectors and so on. All right, so there's this little bit of a, I wouldn't say no man's land, but it's in between. You don't have to have, you can have static members of instantiated classes. Right? When we get into the apple picker, we have a really good example of that. That'll hopefully help. Math library. It's funny. Often I've seen very limited use of the math library, and I wonder if that's just because I don't point out the fact that there's so much in there for people to potentially use. So I want to point it out a little bit more. All sorts of floating point functions in there that will potentially come in useful. Absolute value, for example. If you needed to figure out the magnitude of something, you don't care about the negative or positive. Like if you just want to find out the magnitude of a scalar that might be negative, you can do that. Clamp we already saw, and I forget if it was this class or the other class where we were talking about comparing floating point numbers. And a potential problem with comparing floating point numbers, if it wasn't in here, is that floating point numbers can be very, 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 very small. Or they can also be very, 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 very close to one another. You could have 3.999999999 when you really want to compare that to 4, and the other version of it, for whatever reason, because you calculated these things, the other one might be 4.0000001. Very, very close. You want to consider them the same. They should have worked out to be the same, but they just didn't, because that's the way floating point is. It doesn't necessarily work out to be exactly the same number. That's such a common thing that we have a library function for it. So when you are comparing floating point numbers for equivalence, it is a good idea, a very good idea, to instead of using equals, now some systems will just say, well, okay, 2 floating points, and you're going for equivalence. Maybe I'll sneak this in so you don't realize it. I forget if Unity does that, but there's a built-in function called approximately. And this function knows specifically about the precision with which you can calculate things. It has something called a sigma, which says, okay, this is just about the smallest interval that I need to allow wiggle room in, the smallest error I should be able to accommodate for, to say, and yet say, yeah, these are approximately equivalent, functionally equivalent. Right? So when you're comparing floating point numbers, it's a good idea to remember we have this approximately function available for you in the math library, right? And then we have things like rounding, might come in handy as you try to figure out, if you are doing some kind of really weird mapping from, it is you're keeping track of a floating point number that is the number of hours that have passed, and suddenly you say, oh, okay, I want to figure out, what hour of the day it was, because now you're trying to figure out, is it 7 o'clock? And you say, oh, okay, round that to hours instead of seconds, or instead of floating point, whatever, however you want to do it, right? Things like that. And then you have lots of trigonometric functions, all sorts of your typical functions, power functions, square root functions, sines, and so on and so on and so on. Right? So it's worth knowing, kind of checking out before you wind up writing your own versions of functions, that they do exist. Right? And you're free to use any of them. The more we get into games that are non-deterministic, and even some that are fairly deterministic, meaning the outcome is always predictable, we'll have the need, the desire to use random numbers, right? That's how so many games, almost every game has some degree of randomness in there, from giving the players a chance to roll the dice to perturbing a statistical model in order to get some kind of unique behavior, or potentially unique behaviors, and so on. So we need random things to help us do that, simple random numbers. The two main random, I won't say methods, because they're not, both of them aren't methods. The two main random things that we use, random.value, this is kind of unique, and it kind of trips people up a little bit. I hope it's still doing it the right way. I haven't changed it. If you say random.value, it's funny, it doesn't have parentheses next to it. It isn't even a capital V there, because it's considered to be just a value, just it's a variable. It's it's like a number you just refer to. It's not a function. You're not asking for the result of a function. You're just asking for the random value and what it happens to be at this moment. Right? So you ask for the random value. That returns a floating point number somewhere between 0.0 and 1.0. Commonly, if you want to say, well, I want a number between 1 and 10, or 1.0 and 10.0, you might say, well, okay, subtract the difference between those two, and I know that's how much I have to multiply my random value, and then I have to add 1 to it to offset it, and do some song and dance to come up with your ranges of random numbers. That's kind of a common practice. So common, in fact, that there is a random range function. So if you need to do like, oh, I want to have the enemy appear within this area that is 5 and 10 x and 4 and 12 y, so therefore I want to have the random values within those ranges, you have this handy function for that. And this handy function returns a random number between some minimum and maximum that you provide. You can specify either of those as integers or floats, depending on whether the minimum and maximum values provided are integers or floats. So you provide it with that, it will return the appropriate value. So this is one of those things we talk about overloaded functions a lot. You start to see that in languages like this. I'm sure I must have mentioned that before a little bit. Whereas, if I say, okay, this random range and I pass it 2 integers, it does the integer version, passes that back. Random range, 2 floating point numbers, it knows how to deal with that. Actually uses a slightly different version of random.range, but passes back a random floating point number. Okay? So it's an overloaded function, meaning it has implementations that are specific to the parameters that are being passed to it, right? And this one is extra special and worth knowing some specifics about it here, because the integer version of random range has a feature or has a property that it is max exclusive. Max exclusive. That means that the maximum value here that you provide, it will never give you back that maximum value. It'll only give you up to 1 below that. So in my example here, for example, if I said random range 0 to 10, it will actually give me back 0 through 9. It won't give me 10. That's a practice that maybe goes all the way back to this is used so often for picking between 10 values, right? You want to, 10. You have an array of 10 possible enemy types, and I want to choose one of those, and I'm 0 referenced in my array, so I know I want 0 through 9, right? So it's nice to be able to say, okay, I have a range that is actually a range of 10 values starting at 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the 10 values. So it's a little bit weird and cryptic, and choose your own lore for kind of behind that. But the end result is you have to remember that in case of integers 0 and 9, approximately equal probability. The float version is max inclusive. You get the whole range. You will occasionally get 1.0 if you say 0.0 to 1.0, just like you would kind of expect. So if you want to go further, create your own libraries, consider doing this, right? This is a pure library, a pure math library. It's a static class, meaning it has nothing that needs to persist. It has no way, you cannot instantiate an object from this. It exists only for the purposes of providing functions, right? In this case, the static function. Let's get one of the last things about static out of the way here. Static, what is it? Static is unchanging. A class can be static. So the class itself does not change. It does not maintain some kind of internal state that changes as it goes on, right? At any moment, it is what it is. Static class is basically the same as a non-static class, but the one difference is static class cannot be instantiated. It has no instance variables. You cannot use the new operator to create a variable of the class type. There is no instance variable. You access members of the static class by using the class name. You can't access it by an instance. You have to access it by the class name. Right? Static class can be used as a convenient container for sets of methods that just operate on input parameters and do not need to get or set any instance fields. So I guess I misspoke a second ago when I was talking about the state. Because static, if you have any state to it, it is static across the whole class. It doesn't have instance, no instance values, right? Exposed methods, variables, properties, whatever they are, they all must be declared to be public and also static. So in this case, you see the moment we put that static up there, static class myMath, everything inside there has to be static as well. And it should be public because it doesn't really serve a purpose to be private in there. Yes?
Static classes have member variables as well?
Yes.
And so then can you use getters and setters to change them?
Yes, but I would go so far as to say you're getting into a realm of kind of taboo programming, like using globals, right? So it may or may not allow you to do that at all. I haven't checked in a while just because I don't consider globals to be something that I just want to do, right? So this is the closest we would get to a global value in this sort of programming, right? Static to a class, in the case of where I'm using that to manage instances within the class, that's a useful thing. But statics to statics that can never be instantiated, I would avoid that, because you're getting into I can't imagine a really useful reason to do that. So be careful as you push the envelope there. All right. So 10 minutes left. I want to talk a little bit about strings because we use strings all the time, right? You've all used strings in the adventure game, I'm sure. If you haven't, I'm going to be really, really surprised. And strings are another one of these things that they seem awfully simple, and it's easy to get away with just saying plus equals to add something to the end of a string, or equals to assign a string, and maybe that's just the extent of it. That's your experience with strings at this point. But strings are potentially really powerful, so I like to mention them, the class of strings, and kind of the weird, quirky things about them. I think I refer to a little bit as them being sort of quirky because they are fundamentally, when you think about a string, you sort of think of them as being an array of characters, right? We have some number of characters, a fixed number. Arrays we talked about, arrays have fixed size. So when you add things to an array, you can't just add it to the end, add it to new things, but it feels like we do that in strings all the time. We're kind of like adding things and moving stuff around and so on and so on. So it's worth really considering strings for a moment. So a string is a sequential collection of characters that is used to represent text. This is the textbook definition here, or the Microsoft.NET definition. Sequential collection specifically of system.char objects that represent a string. So they're not really just old school 8-bit ASCII characters anymore. Now they're UTF-16 code integers, so we can know that there's certain values and certain legitimate values. So they're a little bit fancier than that. And where it really gets interesting, by definition, the value of a string object is the contents of that sequential character object, and that value is immutable. Officially, strings are immutable. They are read-only. Because deep down, they are, like we said, arrays like that. So we talk a lot about string manipulation, but by definition, they are immutable. So we're really making new strings from strings. If you look up most of the string functions, it will say, it will return a new string, or return a reference to a new string. But it sort of feels like, sometimes it feels like we're manipulating the same string. But we're not, but it feels that way, which is cool. So there are lots of functions in there that allow us to parse through strings, and then we use the return values of that, or whatever relationships to kind of parse through, do things to create new strings, to manipulate them, and so on. And I find one that's worth pointing out, and this is going to hint at a bit of a case study. I'll try to speed up now. Substring. Substring is a really cool feature of strings that allows you to pick out parts of a string for other purposes. So say you wanted just like the last half of a string that was 16 characters long. You say, okay, starting at position 8, give me the rest of this string. Or starting at position 0, give me the next 8 characters. Right? Do things like that. And you can even use index of to find characters within strings. Right? So this example here is all about kind of separating these pairs of strings, or pairs of components, a key and a value, out of an individual string. So if I said color 1 equals red, it uses our index of to figure out where's the equal in that string. So index of, another great function. And then substring to give me from 0 to the position of that equals. That becomes a string. And then from the position of that equals, or actually one beyond that, for the rest of the string. So a real handy way to kind of turn a string into a key value pair. Right? Something like that. So part of the inspiration for wanting to mention that, to put the seed of a thought in people's heads, some people had asked about creating sort of pseudo consoles. I want to, especially in the adventure game, I want to print out stuff to the player. By default, if you say, well, okay, set the string equals to this, set the text equal to this, it replaces whatever's there and you get new text on the screen. Or you could say plus equals and it puts it kind of after. And sometimes you might be clever with the new line character, and you might add something to what's already on the screen by putting a /n, which is a special escape character, to move it to the next line on the screen. So you can imagine, I'm just going to put /n and add, /n add, put stuff all the way down, all the way down, all the way down. All right, so you can kind of keep adding text to a console window-ish thing just by playing games with this, /n. But the problem, of course, is that none of the text at the top goes away. It doesn't really scroll, it just keeps adding stuff to the bottom. And to really be a useful console window, it wouldn't be nice to have some way of sort of scrolling up or removing the top of the top line or lines. So decisions. How would you do that? How would you implement your idea here? And I'm going to give a bonus feature point if anyone does a good scrolling window, especially if they decide if it's going to be a difference in points between doing it kind of some of the brute force ways versus doing it what I consider to be a reasonably elegant way. So just food for thought because we're running out of time. Can you do a scrolling console window just as one big text box that just has continuous text? Now, if you're just adding stuff with a new line, that's one big text box. Just keep adding stuff to that, but you have this issue of how does it scroll? So should you have something, maybe a new text box for each line in the console? So if you have 4 console lines, as 0, 1, 2, 3, 4, and then the user adds something, maybe you have some sort of effectively a circular queue, and you use your mod function to know I want to cycle between 0, 1, 2, 3, and when I get 4, I want to go back to 0. Right? So if you've never encountered the mod function before, you all remember the mod function? Yes, no, probably maybe not. Mod provided us with the remainder. Right? So if I said 4 mod 4, I get, what's the remainder? 4 divided by 4. I know you know this one. 4 divided by 4, the remainder is, somebody help me. Turn the lights on. 0. So that means, okay, the 4th entry should be put here. 5 mod 4 is 1. So the 5th one winds up here. 6 mod 4, 2. 7 mod 4, 3. 8 mod 4, 0. Right? So we wind up creating what is called a circular queue. Right? We just keep adding. Every time we want to add a line, we increment the line, we do a mod, it winds up getting into one of those values. But the problem we have then is, well, it's still not scrolling off the top, and we wind up with things at the top that should be at the bottom, and so on. So we have to potentially get fancy and do things like split the list to say, show it 2, 3, 0, 1. And then the next time we add something, we show it 3, 0, 1, 2. So you might need, instead of having a text line for each, text box for each line, instead you might have a string that you manage this way, and then you take those values and you assemble them into that text box. Maybe another way to do it, right? So you somehow have to keep track. So it's always a question of this challenge of how does the text scroll to the top data-wise, not visually. So the challenge I have, or that the way I like to see it, because we do like this idea of saying line 1/n, line 2/n, right? That's our version where we just keep adding and adding and adding. If you're clever about the use of substring and index, you can figure out how to create new strings and leave out other sections of strings. Right? So a cool, convenient way without jumping through all hoops and lines and fors and so on to do that sort of thing. And in 1 minute last, if you are referring to this slide, this is going to be the next project. We don't have to really worry about it too much yet. But if you refer to this, this is the first instance where we're going to talk about Project 2 and its requirements. We'll go over that again really on Monday. But if any of you are already convinced you're done with the adventure game and you want to look ahead, it's there in the lecture notes. So, all right. Any questions on anything? If you do have any questions, I know some people have asked about office hours and so on. The main thing, normally I'm trying to monitor, what I mean by office hours these days is that's when I'm sort of sitting around generally trying to monitor Discord unless someone else already has my attention. So that does happen occasionally. So once someone has my attention on Discord between classes, I will be in office hours with them. Or if nobody's around, nobody asks me anything, I'll just be waiting. if you can't make those hours, just direct message me on Discord. Usually the first thing I'll say is, well, can you explain the problem, just in case we need to kind of deal with it asynchronously. Right? If you're up at 4 o'clock in the morning, you have a question, you say, I have a question, can I meet with you? It's better to say, I'm trying to do this, can I meet with you to talk about it? Because then I can think about what it is, or maybe just write to you immediately, and you get up at 2 p.m. when I'm in class the next day. So office hours, consider them just DM on Discord is really the way I run the office at this point. It makes sense. All right. Look forward to seeing you all on Friday, and if you do have any questions, please do reach out. Thanks. And I got to remember to stop the recording for a change.
The quadrants are you on